Alright, so I think I'm recording. We are taking a look at skill packet 3, which is relations and functions. And we're looking at skill 3E. We're combining two functions. We're building a new function through the operations of addition, subtraction, multiplication, eventually division, and also a thing called function composition. So, what's kind of interesting, I think, is that we can talk about the domain of this new function without ever getting an equation for it, without ever getting a formula, because we can use how it was built to describe what the domain of the final result will be when you subtract g away from f. So to find given an equation to find the domain of a function, it's always starts out by thinking, well, it's a set of all real numbers, but you exclude any values of x that cause division by 0. Well, for f, I don't have any variables in the denominator, so there's no value of x that's going to cause division by 0. But I do have to worry about the even roots of any values of x that would cause us to take an even root of a negative number. I can't take the square root of a negative number. This x plus 15 is going to change its value depending upon the value of x. I need it to always be 0 or positive. So I need to restrict x to be bigger than or equal to negative 15. Otherwise, if I'm smaller than negative 15, then this is going to be a negative number and I can't take the square root of it and I can't get a corresponding y value. Now, in the second function, I don't have any radicals to worry about, so I don't have to worry about taking the square root of a negative number. But I do have to worry about division by 0. I do see a variable in a denominator. So this x squared minus 9, I'm concerned, is there any value of x that would ever be a solution to this equation if I set it equal to 0? So yeah, there's two solutions to this equation actually. If I factor this, I might be able to see it more clearly, or I should be able to see it more clearly, that negative 3 and positive 3 add up to 0. So I need to make sure that x is never negative 3 because it'll be undefined. G evaluated at negative 3 will be 1 over 0. I can't have that. And this x here, well, 3 minus 3 will give you 0, and 0 times anything is 0. So these are the two solutions to this equation that will result in this denominator being 0, and we can't have that. So let's draw a picture of the domain of f, draw a picture of the domain of g to help us find the domain of f minus g, because we're going to intersect these two sets. Both of these have to be true at the same time. So sometimes that's hard to see unless you draw a picture of it, or at least in the beginning when you first start studying these things. Negative 15 is smaller than negative 3, and negative 3 is smaller than positive 3. The domain of G, well, I want to have the same window, the same picture, because I need to look at negative 15, negative 3, and positive 3, because those were the boundaries of my other, of both answers. The domain of f minus g, what I'm trying to find, is going to be the intersection of these two. If it's a member of this set and if it's a member of the domain of g, then it will be in the intersection. It will be in the domain of f minus g. So I need to write down negative 15, negative 3, and positive 3. So I come back up to domain of f and say, well, negative 15 was in the domain because it says greater than or equal to. Because that equal to portion, I want a solid dot there. And values of x that are greater than negative 15 are to the right of negative 15. So all of these numbers, all the way to infinity. Now, here in G, there was only two values that caused us problems. Of all the real numbers, these were the only two that we had to worry about. The only two that when you plug it in is the solution to that denominator being 0. X squared minus 9 equals 0 has two solutions. We don't want those to be in the domain, so we exclude them. All of the other numbers are fine. So now we have to decide what to shade or what not to shade. Negative 15 is in the domain of f. Negative 15 is also in the domain of g. If you're in the domain of f and you're in the domain of g, you're in the domain of the intersection, the domain of f minus g. Now negative 3 is in the domain of f, but negative 3 is not in the domain of g, so it will not be in the intersection. And although positive 3 is in the domain of f, positive 3 is not in the domain of g, it will not be in the intersection. Values that are smaller than negative 15 are not in the domain of f. They will not be in the domain of the intersection. But numbers between negative 15 and negative 3 are in both, so they will be in the intersection. And numbers that are between negative 3 and positive 3 are in both, so it will be in the intersection. It will be in my answer. And numbers to the right of 3 are in the domain of f, and they're in the domain of g, so they will be in the domain of the intersection. So here I've shaded the domain of f minus g. That's too many numbers to list, so we use this interval notation to describe this set of infinitely many numbers. This f minus g, start at negative 15 and include negative 15. Increase all the way to negative 3, but exclude negative 3. From negative 3, include to positive 3, and exclude positive 3, and then go 3 to infinity. So here's our answer for problem 9. I hope that helps.